Let's talk about beams. Now, the first thing we need to consider is I told you that the course, this mechanics is divided into 5 different parts. Now, the part one of this mechanics is what we want to consider now, which is we are going to put our focus on beams, where I brought out the lesson outline, and the first thing we have there is what are beams. Now, when you want to consider beam, what should come to your mind is our local bridges that we have, or normally the bridges we are seeing every day. Now, when you draw your mind down to your bridges, you can see that your bridges are made of what? Beams. They are made of what? Beams. Now, the next thing on our lesson outline is what we call support and reaction. Support and reaction. Now, we considered our bridges as our beam, right? Now, the next thing you should be asking yourself is what is holding the beam? Because you cannot tell me that, okay, the beam is lying horizontally and there is nothing holding the beam. It's not possible. So you need to consider, oh, what is holding this beam to stand? Am I communicating? So we are going to consider the types of support we have, and we consider the reactions for each support. Am I communicating? That brings us to the next one, which says what? Types of support. So every beam has its own unique type of support that is holding the beam. Am I communicating? So sometimes you see two supports, and those two supports have their own reaction. So it's left for you to identify the support you are seeing or holding the beam. Am I communicating? Now, the next thing which you have is types of beams based on their support. So what this is trying to tell you is, okay, we have different types of beam. You use these beams that you are seeing on, you use these supports that you are seeing on the beam to identify that type of beam. Am I communicating? Now, what is the next thing? We are seeing what? DOI. DOI. And what's DOI? DOI simply stands for degree of indeterminacy of a beam. Degree of what? Indeterminacy of a beam. Now, somebody will ask me, okay, what is the degree of indeterminacy of a beam? Now, when we are considering the degree of indeterminacy, let me just run through it. Now, degree of indeterminacy is telling you that, okay, what are those external forces you are seeing acting on your support? That is it. Okay, you might have a beam, and you actually see that, okay, we have two reactions, right? We have two reactions for this beam. Those are the reactions you are seeing with your eyes. Am I communicating? Now, how are you seeing it with your eyes is because you know the types of support, abi, and when you've gotten to know the type of support, you should know the type of reaction for that support. That's why you are seeing it with your eye. But there are some forces, reactions that are being calculated, but you are not seeing them. That is where your DOI comes into play. Am I communicating? So you can simply get the DOI of the different types of beam you've recognized already. So sometimes in your exam, what they do is they bring out 4 to 5 beams, and they will now ask you, okay, get the DOI of these 4 beams, get the DOI of these 5 beams. So it's left for you to know how to calculate for your what? Your DOI, and apply it. That's all. Now, what's the next thing we are seeing there? The next thing we are seeing is what we call equation of static equilibrium. Sorry, equation of what? Static equilibrium. Now, why are we considering static here? Why are we considering static here? Now, if you can take your mind back to our bridges, remember, why are we using bridge? Bridge is just like what you can recognize very easily. That's why we are using bridge. But there are other scenarios where beams are being placed. Am I communicating? But the easy scenario where we can identify everything we need to talk about in this part of the course is what? Bridges. So let's use the bridge as a case study. So if you have a bridge, you can see that your bridge is not moving. What is moving is only the load acting on the bridge. Am I communicating? So since the bridge is not moving, what are you considering? Static. Static. So that brings us to what we have here as what? Equation of what? Static equilibrium. We are going to know the equation of static equilibrium, and we know how to apply it in when we are talking about beams and the rest of them. Now, the next thing which we are going to consider is what? Determinate beam and what? Indeterminate beam. Now, how will your question come? Now, your question comes in this manner. They will ask you, okay, we have two types of beam. Identify which of these beam is determinate, and identify which of these beam is what? indeterminate. So it's left for you to look at how to identify each of these beam and get your what? Your determinate beam and your what? Your indeterminate beam. Am I communicating? Now let's take the first one which we have here to be what? What are beams? Episode 1, what are beams? Now what do we have here? What we are simply seeing is in engineering mechanics, a beam is a structural member designed primarily to what? To carry load perpendicular to its longitudinal what? Axis. A beam is a structural member designed primarily to what? To carry load perpendicular to what? Its longitudinal axis. Now, what do you need to note down? What you need to note down is what? Primarily what? Carry load. Carry load. So the function of a beam is to what? To carry load. Am I communicating? Now look at the scenarios we have here. The first one which we have here is the bridge, beams on a bridge, beams on a bridge. Now look at this bridge. From this bridge, what are we seeing? We are seeing what? Our reaction here. We are seeing another reaction here, right? Now what can we say about this reaction? I told you that when you see a reaction, that is, you are seeing a support with your reaction. So you cannot just see reaction without support. So what is that telling you? It's telling you that there is a support here, X1, and there is another support here, S2. Am I communicating? Now somebody will ask me, sir, what is the load here? What is the load is what is moving. This is moving. This is a load. This is a load. This is a load because it's acting alongside a beam. Am I communicating? Now look at the next um figure here. Let's call this fig 2. Now for your fig 2, you can see that beams in a rooftop. Beams in a rooftop. Now I told you earlier that you are not going to consider beams just for bridges. Beams are not only found on bridges. There are other places beams are being found. Now what's the next thing? Is beams in a roof structure. Now look at this roof structure. What are you seeing? You are seeing your column. One, two, three. What are the column holding? The columns are holding what? The beam. So basically, what can you say your column is? This is your what? We can call this S1 to be our support 1. You can call this what? X2 to be our support 2. And you can call this what? S3 to be our support 3. So now, from your support, from the three supports you have, basically you are going to have what? Reactions for these three supports. Am I communicating? But what's our interest? Our interest is to what? To consider what the beam is in this case. Our interest is to what? To consider what the beam is in this case. Now, what's the beam? We're basically seeing the beam here. This is your beam. This is your what? Your beam. And your beam is being covered with what? The rooftop. So in essence, without your beam, there will be no what? Covering of what? Your rooftop. Now let's take another example. Let's take another example. What are we seeing here? Let's call this fig 3. Fig 3. Now for our fig 3, we are basically seeing what? Machine frames. Machine frame. Now for your machine frame, what are you seeing there? The first thing you are seeing is your what? Your beam already. Abi? Now since you are seeing your beam, the next thing you should consider is, okay, what is now holding this beam? So basically we are having what? We are having one S1 support 1. We are having another one S2 support 2. We are having another one S3 support 3. And we are having the last one S4 support 4. Now, these supports are holding what? Your beam. This is your beam here. So your support is holding this beam. And what is happening? Your machine is placed on the beam. So in essence, you cannot see a beam without what? A support. And you cannot see a support without what? Reactions. Am I communicating? Now look at the next one, our building. Our buildings. Now, for this building, what are we seeing here? For this building, we can call this fig 4. Fig 4. Fig 4. Now, from what we have here, what are we seeing here? We are seeing our first decking, our second decking, right? Now, why am I using decking? Decking is decking is the word we we normally use as civil engineers, as architects. Like this is your first decking. So what your decking is acting as your what your beam. Am I communicating? Your decking is what acting as your beam. Now somebody asked me, sir, he said, we cannot have a beam without a support, right? Yes, there is also a support here. And what's the support? What are you seeing here? And what are you seeing here? Am I communicating? So basically, you can see beams in different scenarios. We can have beams in different scenarios. Now let's take an example. Let's take an example. Now look at this example. They said a concrete slab resting on two walls act as a beam. This is a concrete slab. This is the concrete slab, right? This is your concrete slab. And what happened? It is resting on wall one, which is your what? Your support one, and is resting on what? Wall two, which is the what? Your support two. Now, looking at what you have here, what can you say? What you simply do is you have the support one, you have the support two. These supports are what? They are holding your what? Your slab. Am I communicating? And this slab, this concrete slab, is a what? A beam. What's the next thing you are seeing? You are seeing a guy and a lady walking across what? The beam, across the concrete slab. Now what can you see? These two walking here, these two are a good example of what we call the load, because what is happening is they are acting on the concrete slab, and if the concrete slab is not strong enough, what happens? The concrete slab what? Collapses. The concrete slab collapse. Am I communicating? But in this case, the concrete slab is not going to collapse. But what happens? It bends. It bends. So what is it? What happens? What is happening is you have your support one, your support two, and you have what? Reactions for each of these supports. Am I communicating? So in essence, we've already known what is a load. We've already recognized what a beam is. We've also recognized what our support, right? And we also recognize what is our what reaction. Am I communicating? So in essence, our interest is these four things: load, beam, support, and what reaction. Now let's move over to the next episode. What's the next episode? The next episode is what we call support and reaction. Support and reaction. We've been talking about support. We've been talking about support. What is now this support that we are talking about? Now, basically, we have three types of support. We have what? Three types of support. And what are they? The first one, which we have, is what we call the pinned or what? Hinge support. The what? Pin or hinge support. The what? Pinned or hinge support. Now, sometimes in exam, sometimes in exam, you are going to see, you are going to see this. You are going to see a support of this nature. Now, if you see a support of this nature, what should come to your mind? This is a what? A hinge support. This is a what? A pinned support. Am I communicating? Or you see your hinge support in this manner. You are going to have a support of this nature. You're going to have this, and you now have this. So sometimes they use this to represent your hinge support in exam, or they use this to represent your what? Your hinge support in exam. So just note. Now, what's the hinge support? Your pin support or your hinge support prevents translation. Prevents what? Translation. And what's that translation? Movement. What's the translation again? Your translation is what? Movement. Now, what your pin support does is it's going to prevent is it prevents movement in both what horizontal and vertical. So meaning your support is not moving horizontally nor what vertically. But look at the unique thing here. Directions horizontal what and vertical direction but allows what rotation. But allows what rotation. So what you need to note is when you're considering your hinge support, what happens? Rotation is what is necessary, not the movement of what horizontal or vertical. Am I communicating? Now, what's a good example of our hinge support or the pin support? A good example is our wooden doors. Our wooden doors is a good example of a pin support because what happens? Your wooden door is not moving horizontal, not what vertical. It's not moving vertical or horizontal. But what happens? It's rotating. So you are closing it, you are opening it. That is a rotation. Am I communicating? Another good example is what we have here. Our windows is a good example of our hinge support because your windows, you are not closing it, you are not opening it. Apart from the window which you are moving it this way. When you are moving a window like this, there are some windows that you can open and you can close, but there are some windows, yeah, you can move it like this and you can move it like this. Let's look at that. Now let's consider the next type of support, which we have to be our what our roller support. And what happens? Roller support prevents vertical movement, but only allows what horizontal movement and rotation. Horizontal movement and what rotation. So what's the unique thing about the roller support? The unique thing about the roller support is what horizontal movement and what rotation. So what's a good example of our roller support? Is the window we are opening it this way and we are closing it this way. Another good example is our sliding gates that we have at our homes. Am I communicating? The sliding gate is exactly a good example of it. So let's say this is Musa. This is Musa, right? Musa is our gate man. This is our gate. This is our gate. Now, what happens when you have your gate? You are going to see some balls on your gate. Actually, they put two balls, two rolling balls. Now, what happens is look at the gate here. This is the gate from this point to this point is your gate, right? When Musa wants to open this gate, Musa rolls the gate to this point, and when Musa wants to close the gate, Musa now rolls the gate back to this point. Am I communicating? So this is a good example of please, this is not a motor, this is not a car. I'm just using this as a gate. So this is our gate here. Don't take this to be a car. So that's our gate. So this is a good example of a roller support. Now, how do you identify a roller support in your exam booklet? Sometimes your roller support is as this, like this, is actually drawn like this. So this is your roller support, or you see your roller support in this manner. You are going to have this as your roller support, this as your roller support. But most of the time, you are going to see this, or basically, you are just going to see a circle and this. Sometimes they will leave it like this as your roller support, this, and sometimes they will give you this. It depends on how you are giving the question. Am I communicating? So keep your eye down to identify your hinge support and your what your roller support. Now let's consider the next type of support, which we call the fixed support. The fixed support. And what's the fixed support? Now what happens is for the fixed support, your fixed support do not move. What happens is for your fixed support prevents all movement, including rotation. Your fixed support prevents what? All movement, including rotation. Now, what's that trying to tell you is for your fixed support, there's no movement that is occurring, whether what? Vertical movement, horizontal movement, or what? Rotation. what happens is your fixed support is just fixed. It's just at a point. That's your fixed support. It's just at a point. Am I communicating? Now, your fixed support, sometimes in exam, you see your fixed support in this manner. You see a support like this. You see a support of this manner. Am I communicating? Now, if you see a support of this manner, you should actually know that what you are considering is a what? A fixed support. Now, somebody asked me, sir, how can we identify a fixed support? What is a good example of a fixed support? Now, for your fixed support, a good example of your fixed support is your electric pole. Now, look at your electric pole. Your electric pole is just what? Fixed. It's just firmly pinned on the what? On the ground. Now, what happens? Is there any movement for your electric pole? No. Another example is our solar light, our street light. Your street light, is it moving? No. So those are what? They are good example of what? A fixed support. Now I told you that when we are considering support, support works in hand with what? Reaction. Am I communicating? Support works hand in hand with what? Reaction. What's the first thing we considered was? The first thing we considered was a pinned slash what? Hinge support, which I said this is your pinned slash hinge support. And what happens? Remember, for this support, what happens is it's not moving horizontally nor vertical, but it is what? Rotating. Abi? Now, for your hinge support or your what? Your pin support, we have two types of reaction. The first one is this reaction here, which we can call it arrow Y, and another reaction like this, and we can call this one arrow X. So your hinge support is characterized with what? Two reactive forces. Now, for the next support, which is your roller support, I said your roller support is always like this in your exam. Now, what happens is for this type of support, movement happens horizontally, but not what? Vertically. Movement what? Happens what? Horizontally, but not vertical. So how many types of reaction do you think your roller support is going to have? Your roller support is going to have just one reaction, which is what? RY. Am I communicating? Now, for the last type of support which we have here, which is what? The fixed support. I said the fixed support prevents all movement, including what? Rotation. So what is the reaction you are going to see for your fixed support? You are not going to see any any movement. So what that tells you is it's going to have three reactions. Why? It's not moving vertically, that's one. It's not moving what? Horizontally, that's two. And it's not moving what? Rotationally, that's what? Three. So basically, you're going to have three reactions. So you have one, arrow Y, you have another one, arrow X, and you have the last one due to what? Rotation, which is what? RT. Am I communicating? So basically, we what? Considered three types of reactions. We have considered three types of reactions with their support. Am I communicating? Now let's look at what we have here. Let's look at the diagram we have here. Let's look at the diagram we have here. Now from what we have here, we can see our what? Our hinge support here. And he said your hinge support prevents what? Movement, prevents movement horizontally and vertically. We are seeing what? Our reactions. Come to the next one, which is our roller support. What are we seeing? It allows us horizontal movement. So we are going to have your vertical reaction. Now, what's the next thing is your fixed support, which is this. And for your fixed support, what are you seeing? You're basically seeing your what? Your horizontal, your vertical, and your what? Your rotation. The one due to what? Rotation. Am I communicating? Now, what's the next thing we need to consider as this course will be going on is what? Episode 3. Episode 3. And what's episode 3? Episode 3 simply tells you that beams based on their support. Beams based on their support what? System. So basically, our interest here is to know the support for a particular beam. For you to recognize a particular beam, you need to know the support system that you are seeing on that beam. Am I communicating? Now, the first one which we are going to consider is what we call the simply supported beam. The what? Simply supported beam. Now, what's the simply supported beam? Let's note this down. Let's note this down. The first one which you have is our what? Simply supported beam. Supported beam. Now, for the first thing you are seeing there is this is a beam where the supports are placed at both ends of the beam. For you to identify a simply supported beam, look at that beam. What are you seeing? What is the unique thing? It is where what two supports are placed at both ends of the beam. So basically you have what your support here and you have what another support here. It doesn't matter the type of support you are having. You can have a fixed support and a roller support. But what is the unique thing you need to note is what for a simply supported beam, you need to have your support fixed at both ends. Let's say this is point one and this is what point two. So you must see your support at both ends of the beam, and that tells you that we are considering what a simply supported beam. What's the next one? Overhanging beam. Overhanging beam. And what's an overhanging beam? An overhanging beam, these are beams where the supports are not necessarily placed at both ends. So your supports are not what necessarily placed at both ends. So at you can see your support at one end and you can see the support placed at this point, not necessarily at both ends. But if you see your support here and you see your support at this end, you are considering what a simply supported beam, not overhanging beam anymore. Am I communicating? So this is a good example of this is what is this is an overhanging beam because you are seeing your support here, you are seeing another support placed at this end, but not at the end of the beam. Am I communicating? So this is a what an overhanging beam. The next type of beam we are going to consider is what we call the continuous beam. Continuous beam. And what's the continuous beam? The continuous beams are beams with multiple supports. They are what? Beams with multiple supports. Am I communicating? So if you have a beam and you are seeing more than two support, whether fixed, roller, or hinge, you are seeing more than two, then you are considering what we call the continuous what? Beam. Then we are seeing what is called what? The continuous beam. Now, what's the next type of beam we need to consider is what? A disrupt cantilever beam. A disrupt what? Cantilever beam. Sometimes students confuse themselves with a disrupt beam, a disrupt cantilever beam, and a what? A propelled cantilever beam. Let's consider what a disrupt cantilever beam is. A disrupt cantilever beam are beam fixed at one end and free on the other end. Take this. A dis a dis a disrupt beam, cantilever beam, a disrupt or what? Cantilever beam. These are beams fixed at one end and free on the other end. These are beams fixed at one end and free on the other end. Am I communicating? So in essence, what they are trying to tell you is when you have a disrupt beam simply tells you that okay, for my beam, I'm always having a fixed beam at one end, whether at the right or the left. You have what? A fixed beam. But for a propelled cantilever beam, these are beams that are fixed at one end but has a support at the other end. Don't mistake your propelled beam with your simply supported beam because both beams has what? Support at both end. But what is unique about propelled beam is one end is fixed and the other end is placed with maybe a roller support or a hinge support. That's the difference. So in essence, we have two types of cantilever beam. Sorry, in essence, we have, let me take this down. What am I doing? So we have types of cantilever beam. And we said one of them is what we call the disrupt, and the second one is what we call the what propelled. So don't get yourself confused. These two beams, these two types are an example of what a cantilever beam. So it's left for you to know the particular cantilever beam which you are considering. So sometimes when they give you your cantilever beam to identify, most of you just put it to be what? A cantilever beam. Yes, it's a cantilever beam, but what type of cantilever beam are you considering? Am I communicating? Thank you. Now, what's the next type of beam which you are going to consider here? Is what we call the fixed ending beam. The fixed ending beam. Now, what's the fixed ending beam? These are beams fixed at both ends. These are what? Beam fixed at both ends. So basically, let's take this as an example of a fixed beam. We say that this end you have a fixed beam. On this end, you have what? Another fixed beam here. So what are you seeing? You're having one, two, and what? Three. You're having one, two, and what? Three. Am I communicating? So this is an example of a fixed ending beam. So if you are given these 6 types of beam and you are asked to identify these beams, you can be able to identify each of these type of what? Beam. Am I communicating? Now let's move over to the next episode. And what is the next episode? The next episode is what? Degree of indeterminacy. That's DOI. Degree of indeterminacy. That is what? DOI. Now, talking about degree of indeterminacy, what's degree of indeterminacy? What's degree of indeterminacy? That should be the first thing you should ask yourself. Now, when we are considering your degree of indeterminacy, we are basically talking about the number of unknown reactive or what internal forces that cannot be what determined using only the basic equilibrium equation. I come again. DOI simply tells you that, okay, what is the number of unknown reactions or internal forces that cannot be determined using only the basic what equilibrium equation. So you cannot determine these internal forces apart from you knowing what the basic equilibrium equation to use to determine what these forces. Am I communicating? And what's the equation? The equation simply tells you that for your DOI is what? DOI, degree of indeterminacy, is equal to what? R minus 3. R minus 3. And what's that R there? Your R simply stands for what? Total number of what? Reactive acting on the beam. Total number of reactive forces acting on the beam. So that R is simply telling you that, okay, what are the reactive forces you are seeing already? It is what? The reactions you have for that particular beam. Am I communicating? Now note, when you consider your R and you now know your DOI, what tells you is that what? For your DOI to be equal to 0, that means that beam is what? Statically what? Determinate. For your DOI to be equal to what? 0, that tells you that your beam is what? Statically what? Determinate. But in a case where your DOI is now what? Greater than what? 0. So in essence, what they are trying to tell you is, for your statically determinate beam, your DOI after calculating must be equal to what? 0. But for your indeterminacy is what? Your DOI must be greater than what? 0. Am I communicating? Now, how can we identify if the various type of beam which we considered, if their DOI is actually, if the beams are actually what? Statically determinate, or the beams are what? Statically what? Indeterminate. Now let's take the first one as a case study. Let's take the first one as a case study. What do we have as the first one? The first one which we have here is what we call the simply supported beam. Now for this simply supported beam, we want to calculate for the DOI of your simply supported beam. Now for you to calculate for your DOI, I told you your DOI is simply what? R minus what? 3, right? Now, how do you identify your reactions, the known reactions here? What are we seeing here? We are seeing what? A hinge support. And what are the reactions we are seeing? We are seeing one support and the what? The other support. What are we seeing? A roller support. And what are we seeing? What can we say? This is what? One support. So in essence, we have what? 3 minus what? 3. And that gives us what? 0. So in essence, you can say that your simply supported beam here is a what? Is a statically determinate beam. Statically determinate beam. Now let's go over to the next one. What's the next one? The next one is what we call our what? Our overhanging beam. Our what? Overhanging beam. Now for your overhanging beam, what are you seeing? You are basically seeing your support here. You are seeing one support here. And what's that support? We have one support here, we have another support here. So in essence, we have R minus 3, right? Now what's your R? We have 3 minus what? 3. And that gives us what? Z. So you can also see that your overhanging beam here is what? Statically what? Statically what? Determinate. Now let's go over to the next one. The next one is now what? Our continuous beam. Our continuous beam. Now, what can we say about your continuous beam? Look very well, look very closely. You can see that what you have there, they're basically what? Three support, right? So you're basically seeing this support here. I see my cursor. You are seeing this support here. You are seeing another support here, and you're seeing another support here. So in essence, we have what? R minus 3, right? So we are seeing this support here, and this support is an example of a hinge support. So we have two here, we have two reactions here, we have one reaction here, and we have what? One reaction here. Why are we having one reaction here and one reaction here? Because these are what? Roller support. But the two came about us knowing that this is a what? This is a hinge support. So we basically have the 2 plus 1 is 3 plus 1 again, that's 4. So we can see that your R is what? 4 minus 3. And what's 4 minus 3? And this is actually what? 1. What do we say our beam is? Remember the two conditions here. For the first condition, we said the condition 1 is what? Your DOI must be equal to what? 0 for it to be what? Statically what? Determinate. But when your DOI is now greater than 0, then it is what? Statically what? Indeterminate. So is 1 greater than 0? Yes, 1 is greater than 0. And that tells us that your beam is what? Statically what? Indeterminate. Am I communicating? Now, what's the next beam which you need to consider? The next beam which we are to consider is what we call the disrupt beam. And what's the disrupt beam? On this beam, we basically have one end being what? Fixed. Am I communicating? So we are going to have three reactions here. Three reactions here. So what's our DOI? Your R minus 3, your DOI will now be simply what? 3 minus 3, right? And that gives us what? Z. So you can see that your disrupt cantilever beam is a good example of a statically what? Determinate beam. Now, what's the next one here? The next one here is what we call the propelled cantilever beam. The what? The propelled cantilever beam. So what you do for me is you get the DOI of the propelled beam. So you have to get the DOI of this beam. and you have to get the DOI of your fixed beam also. You get the DOI of your fixed beam, DOI of this beam, and what you do is you drop it on the comment section. Drop it on the comment section. Now, what's the next thing we need to consider? What's the next thing we need to consider? The next thing we need to consider is what we call the equation of static equilibrium. Equation of static equilibrium. Let's take that down. Equation of what? Static equilibrium. Equation of static equilibrium. Now, static equilibrium equation, there are of three types. Static equilibrium equation, there are of three types. When you are asked to name the three static equilibrium equation, the first thing that should come to your mind is what are they, right? Now, the first one is what we call all forces, all forces moving towards our horizontal, it's what? Zero. Forces moving towards the horizontal is zero. So basically, what we do is we represent it as sigma f of what? X is equal to what? Zero. Now, on the Cartesian plane, what is here is your x, this is your y, and this is your x, right? This is your x, and this is your what? Your y. So your forces moving along this axis is what? Equal to what? Zero. The forces moving along this axis is also what? Equal to zero. So basically, what's the next one? The next one is number two is what? Sigma f of what? Y is also equal to what? Zero. Am I communicating? And what's the last one? The last one is basically what? The number three is basically what? Summation of moments about a particular point is equal to what? Zero. So basically we have three equation of what? Static equilibrium. We have sigma f of x is equal to zero, sigma f of y is equal to what? Zero, and summation of moments about a particular point is equal to what? Zero. Am I communicating? Thank you for this class, and thank you for staying behind for us to complete the lesson outline for part one of engine 203, engineering what? Mechanics. Stay tuned to get the video for our next episode. Thank you.